Hello, we're here at the 2021 International Workboat Show. I'm with Cole Van Gundy of Crowley and David Lee of ABB, and we'll be discussing that groundbreaking new all-electric tug, the E-Wolf. I'd like to start by asking Mr. Lee what he thinks about the integration of ABB's work into the design of the E-Wolf.
Thanks, Max. I appreciate it. So it's been a long journey with our Crowley team here, and there's been a lot of different iterations along the line as well. We worked with Crowley very early on deciding how do they operate this vessel. Is it going to be operated the same that they have today, or is it going to be a completely different design? We use a lot of that information from the current vessel to design the power package here. It's a kind of a different thought on how you design these tugs now. It's not just I need an engine of certain horsepower, it's how much energy do you need? And that's really what we came down to, is how much energy you need, and it goes into how many batteries do you need. So it was a great process with the guys at Crowley. I think our biggest struggle was trying to figure out how to put everything in one of these. They have nothing but muscle in them, that's what a tug is, but they don't have a whole lot of room. So that's really, I think, the biggest thing that we got to on the ABB side was how are we going to get all this stuff in, and we were able to modify our DC grid in a way to do a couple L shapes to put it into the tug, and with Cole and his guys after that, we came with a wonderful design.
Cole, how did you find the process of beginning this project? How did Crowley bring together the various parties, and especially working with the Port of San Diego to come up in the very beginning with this design?
Yeah, well, thanks for having us here. So this originated with the operators. So the operators saw the operational need to have a fully electric tug and kind of push the industry. The technology is here. So how can Crowley leverage that technology that's in the industry to really change the culture and try to decarbonize the maritime footprint. So we started with the needs assessment, understanding what was really needed to meet these requirements. Operations drove that, and us on the design team really fed or listened, took down the program requirements, and developed a solution that would work. We worked with a number of subcontractors initially to be that electrical backbone, that integrator, and ultimately landed with ABB. But to today's point, we really wanted to put together a package that met the requirements, but also was in a nice contained type package. And you can't do that by just taking an existing hull and putting batteries in it and making it a fully electric vessel. So in this case, we designed a completely new hull shape, from the keel up, and incorporated a whole bunch of new innovative features within the platform to really provide one of the best electric tugs there are.
What did San Diego? What was their input into the design? Did you receive from them a list of things that they wanted to see in the design?
Yeah, so San Diego was a critical partner. They really wanted to have a full electric vessel in their port. So they worked with us, to help define some of their requirements. But really it was, keep pushing our ships in, that you guys have been doing for many years. But also, do it carbon free, out on the water. So in this case, we came up with the fully electric tug. How that's powered. It doesn't care. It can get the electrons from anywhere, and in this case, we're getting those electrons from the grid.
So for ABB's role, ABB is providing the electrical system to the hull that you guys are providing. How was that integration? What were the challenges to that integration? And on the other side, in what ways did all-electric power facilitate the design?
Well, I can tell you this. Number one, I want to go back to one of the things Cole said, where they worked with their operations group from the ground up. At ABB, we're not, in our marine group, we're not just a component that we're going to sell you this and it's going to fit everything. we work with these guys from the ground up to decide what system fits their operation the best, all the way from the batteries to the DC grid itself. And that really started happening about that time where we're analyzing all the data from their tugs and trying to figure out which system to put in here. It was an iterative process between the two of us. We couldn't make a change without knowing the change was coming, and could we do it, could we not do it? And then also at the same time, once Master Boat was selected for the project, really getting that good old shipyard, what can we actually do in a vessel to help finally tweak the design that we had. So all those came together, and you see what we have, the product behind us.
What are the advantages, Cole, to the port itself in having an all-electric tug? In what way does that fit San Diego's vision of their future?
Well, so not only does it fit San Diego's vision of the future, but also fits within Crowley's vision of the future. So Mr. Crowley has come out with a sustainability commitment to be the most sustainable maritime company in the Americas by 2025, and that's a tall order. And he wants to put his money where his mouth is. So the E-Wolf was a perfect platform to do that. So the E-Wolf itself will reduce its carbon footprint by 178 tons of nitrous oxide, 2.5 tons of diesel particulate matter, and 3,100 metric tons of CO2, all without burning a single drop of fuel. A traditional tug operating down in San Diego now consumes 30,000 gallons of diesel a year, and this vessel is projected to burn 0.
Oh, I'm sorry, go ahead.
No, I was going to add on one thing at the very end there, and I love all these things because it's where our industry needs to move, and it's awesome to see the Crowley's putting their stake in the ground and saying, this is our way forward. We talk about the emissions reductions, we talk about the vessel operation itself, but one of the things that we don't talk often enough about is the community and the results they're going to feel. So you have things like very little noise coming out of this, right, compared to a traditional diesel tug where you have the main engines firing, that really low noise that we always hear. The other part of it is you don't have any black smoke. So there's the port is integrated with downtown, and there's a lot of nice places there around the port. So you're outside having a nice dinner, and you have all this big lumbering towboat going past you, spitting out the black smoke. Now, you may not even hear it, and definitely you're not going to see the black smoke coming out of the top of it.
And of course, you have the reduction in the possibility of pollution from an oily bilge, which you have not got.
For sure, that's exactly right.
This vessel has no rotating oil pieces of machinery down below the waterline. So this has generators on the main deck, but that's only to be used in emergencies, or if you need to reposition the vessel to a different location where you don't have access to a charging station, say going between San Diego and San Francisco.
So you'll be refueling the vessel, of course, your your electrons and protons,
right,
from your Cochrane shore-based outfit.
That's correct.
How will that particular setup benefit the port, and how will it benefit the vessel?
Yeah, so because this is an innovative solution, we have to come up with how we're going to charge the thing. So what we've developed along with Cochrane is a 3 megawatt battery system onshore. That is charged from the grid at a reduced rate. So that way we're not impacting the grid, and we can rapidly deplete the batteries onshore and charge the vessel. The vessel's projected to only need to be charged once a day. Can be charged at about 1 megawatt per hour. It's got 6.3 megawatts of storage capacity on the vessel itself, and again only three onshore. So what we're able to do is not put an induced or increased load onto the grid, and kind of trickle charge the vessel in the meantime.
Plus, you're not limited to what the grid can supply because you've already got it in your shore-based power unit.
That's right, and one of the things that I really like about the design and how it's coming together, again, we all know how the power grid is in California. The last thing you want to do is put extra stress on it. And I'm just a dumb old mechanical engineer. And I always think of electrical cables as pipes. So if we had a cable coming off the power grid going into the boat, there's only so much power that you can get into the boat. With the shoreside battery at this point, we have essentially a dump valve where you could just dump that power, kind of what Cole was saying, into the vessel, you get it back out there, to continue the revenue generation that's there for. And again, all at the same time doing it under zero emissions. That's really what the port pushed for on this project is I want a zero emission tug in my port, and that's what we got to.
And to Dave's point, how those electrons get to the port, the vessel doesn't it doesn't care. So using fuel cells, renewable energy, from hydropower or from offshore wind, this vessel fits a platform, outside of just San Diego. It can be really used, I think, heavily in the offshore wind space, but also up and down the West Coast, Gulf Coast, and East Coast.
And that goes, I know we're rambling on a little bit here, but it's just it's so cool to talk about these topics. The one thing, when offshore wind comes in, I mean, this is the whole transition we're in the middle of right now. And versus waiting for offshore wind, so it's truly zero emission from well to wake. Crowley, again, took the step forward saying, no, we're building it today. Because if I build a boat today, then it's going to be around for 35 years when offshore wind is already coming in. So it's too late at that point. I want to build the vessel today and get the advantage of true zero emission operations as soon as possible.
And speaking of which, David, tell us about the fuel cell technology that ABB is obviously very interested in developing.
Yeah, so we see hydrogen as truly one of the steps to get to zero emission. And we do a lot of different work with several different fuel cell companies out there. We're somewhat agnostic on the selection, same thing with our batteries, and we went through that selection process with Crowley. But we see fuel cells in many different ways. It could be the shore-based system, where you have compressed hydrogen, or like the boat we announced this week, you could have a methanol tank at that point with a reformer. You're cutting those emissions immediately at that point in time compared to what we do. But fuel cells are definitely going to be there in the marine industry. We're working on several different projects where it's a requirement for fuel cells and batteries. It's one of the things that we haven't talked about very much. A fuel cell is also kind of slow to ramp up, slow to ramp down. So you need the battery there to take those immediate loads that you would have. So they still go hand in hand. You'll see a battery system with a fuel cell system on these commercial workboats, for sure.
So you'll see the two of them on board working together.
That's exactly right. Yep. Because there's still some of those demands in this industry of you need to get here, you need to get out of the way here, and the fuel cells just take a little too long to get that power to the wheels, so that's why you have the battery to take care of it.
And isn't that, Cole, one of the advantages of an all-electric tug is that you have more immediate power response?
That's right.
To the propeller than you would with a conventional diesel.
Yeah, that's right. So you have the immediate response, utilizing an electric motor as opposed to waiting for the diesel to ramp up. One of the also interesting features of this vessel is when the vessel is being drugged behind a ship today. Right now, that's just lost energy. Today, now we can charge the batteries as we're being drugged behind the ship. So utilizing some of ABB's automation, it's going to change the way that maybe the vessels are used today. Now maybe the tug is hooked up, maybe very close to harbor. Now maybe we're going to hook the tug a little bit earlier so that we can capitalize on some of that free energy coming from the ship, to charge the tug.
And I want to add one thing on there, and again, I'm going to go back to my good old, I'm just a country boy for the farm, right? We always have trucks on the farm. Ford, GM, the rest of the manufacturers, they do a great job of showing you need torque. You need torque to get that trailer moving. That's the first thing they talk about. Right. Then you need power for the sustain. What we've always needed in the tug industry is torque to get that container ship moving one way or another. And with 100% torque at zero speed now, the captain's going to operate these vessels completely different, because what they've done in the past, that power and torque curve follow each other, so you had to hammer down to get the torque that you required along. Here you don't have to. You have that torque immediately available, so the operation of these vessels are going to be different than how they operate today.
And that's been one of the challenges, with new tier requirements is that initial, startup of the propeller. That's very difficult on some medium speed vessel or medium speed engines, so you have to come up with innovative ways to actually overcome that. Because you can't always fit a high speed engine, or high speed engine is always the right engine put in there. With an electric motor, you don't have those problems.
And that's only one of the many advantages that you have from electric power. clean engine room,
That's right.
reduce vibration, reduce noise. Wouldn't you say that this is going to be a net plus for the crew as well?
Yeah, the crew and the environment. You know, how many times have you ever gone down into a tug engine room and been in an air-conditioned space? Probably, probably never, right? Right. So the switchboard room and the battery room are both air-conditioned. You know, a nice clean energy. You know, think of it as a clean room. I mean, those we were putting switchboards in dirty rooms, and you know that comes with its own operational challenges. No,
right.
let's make it a conditioned space to improve the operational profile of the vessel.
And it also works for the navigating side.
That's
in
true.
that you have reduced vibration, and of course this brings in ABB's vision and other command and control systems that will allow the operator of the vessel much greater capability than he would have had without it.
For sure, and so on the tug, Crowley again selected us to have our ABB Ability Marine Pilot Vision and Marine Pilot Control System. The pilot system, the vision system, is there to make the captain's job easier.
Describe the vision system for us.
So vision, it utilizes a lot of the same electronics that are there today, radar, so forth. We do put cameras, LiDAR, a lot of what you need to see things you normally wouldn't.
LiDAR being a ranging system,
That's
right?
exactly right. Same thing as electronic charts. So we can take all that and overlay it on one screen. So now at that point in time, you know where you're supposed to be in a channel, you know where there's a shoal, you know all these different things. You normally have to flip through a bunch of different screens or look here, look there. At the same time, the system will also alert you. So if there's a pleasure craft coming quickly across your bow, normally it's not in your line of sight until maybe it's too late. This system will now alert you, hey, there's a vessel moving or a craft moving at high speed, getting ready to cross in front of you. So that's the vision system. The control system's another portion of that, again, to make their jobs easier. You can do single joystick control. It's built on our DP. We don't call it our DP system because we can do so much more with it. We have a remotely controlled ferry that we've proven in Helsinki. We also have a remotely controlled tug in the Port of Singapore. So it's been proven that we can do it. And same thing will happen with the Crowley project in due time. But a lot of the things that we had to make sure that we talk about when we talk about these systems were they're remotely controlled, but there's still people on the vessel. Today,
Right.
the important part about what Crowley's doing is station keeping, is single joystick control. Same people are still going to be there because they're necessary for the systems the way they're designed today.
Well, for the foreseeable future, of course, they will have to be on board.
For sure.
But that leads us into the issue of how far will this technology be able to take us? We're not really looking at total autonomy, are we?
No, I think what we
Even with crew on board. I mean.
Exactly. I think in a vessel like this, we're looking at this as a step to who knows what in 30, 40 years. Again, I can't believe we're sitting here talking about an old battery tug. It's pretty amazing how the technology is really spinning up. But this is one of those steps to get us there. There is so many other things that we would have to figure out on a tug and the operation of a tug, all the way down to, again, a captain sometimes can feel a vibration if they're pushing too hard on one side compared to the other, and you can't do that in systems like this. What you can do, again, is make their job easier by taking some of those menial tasks away from them. And so that's really what these systems are set up for and why Crowley selected them for the vessel.
Yeah, and just to add on to what Dave was saying, you know, these systems are not going to be replacing mariners, right? They're there to augment, you know, the mariners' abilities and make it a safer environment. It also fits in well with Crowley's commitment, you know, to a digital transformation, trying to leverage technology and automation, you know, to make, you know, our operations more efficient and safer, not only for our people, but also for the environment.
Well, that's one of the beauties of the design, is that you can take whatever innovations that come up in control and command and perception and integrate them into the vessel without any major changes.
That's right, and we can look at that data, you know, after the fact and understand how to improve our profile, our operating profile, our efficiency profile. All that can be done by you know, ABB systems to really understand how are we doing ship jobs today? Can we do it in a more efficient manner? You know, maybe sometimes the operators are are leaving the dock based on their experience, but they have to look at tidal changes, they have to understand where the vessel's coming in, and they're doing all of those calculations either by hand or in their head. By why not use technology that can do that for you and say, hey, why don't you go 3 knots instead of 4 knots? This is going to be your power consumption, to get to this vessel.
And the beauty of the ABB system is, especially for a ship handling tug, is that you can actually integrate your displays and your sensors with that of the vessel that you'll be escorting or maneuvering.
Yeah, and that's some of the stuff we're looking for at the future is not only the vessel you're escorting, but also the other tug guys that are there sometimes that you normally can't see on the opposite side.
Oh, yeah.
So you would have your screen where you can now see what he or she is seeing at the same time in your vessel. So you're not just relying on radios at that point in time. So
which is quite common in ship handling.
That's exactly right. But wouldn't it be great to see what they're seeing at the same time they're talking to you? So that's the type that's really
not only great but safer.
That's exactly right.
Yeah,
and
absolutely.
That's the whole, as Cole said, this whole technology transition and where we're going to. It is, and it's going so fast. And when I was in high school, and it seems like forever ago today, but my cell phone was that big hanging off my side. And that cell phone, the best technological advance it had was the backlight in it, right? Look at 20 years now, and the iPhones and everything else that we have, and the power that they have behind them, it's absolutely ridiculous.
And we have a generation coming up that is so used to joystick control that for them, moving into a joystick wheelhouse is just like being in their mother's basement and doing what
they're
they've
just playing
always
a video
done.
game,
just
right?
like our kids, right?
That's right. Yeah. Our kids are either on their phone or on their video games, right?
Right.
Yeah. We'll just bring that to them in the real world now.
There were some other features to the E-Wolf that I thought were very nice safety features. One being the man overboard rescue ladder on the side.
Yeah. So like we said, so we designed this with the operators from the keel up. Completely new vessel. Obviously with Crowley's operational experience and knowledge, they can see where the mariners are struggling and where there's potential risk, for injury. So in this case, we integrated a self-rescue platform or self-rescue zone. So what that is an integrated ladder into the side of the vessel, so that should one of the mariners fall overboard, they can rescue themselves. Some other things is how we laid the deck out. There are no tripping hazards on the deck. The staples up forward, so mariners can't get between, the staple and the line as a pinch point. And then of course, because we have no stacks, we have 360 degrees of visibility.
Absolutely.
So that operator can be sitting in his station and he can see all contact points on the vessel, and he can also see the mariner down on the vessel to really try to make sure that you're operating in a safe environment, while in a sustainable way as well.
Yes, because in a conventional tug, the operator has to go aft and try to see what he can see between the stacks.
That's right.
That's exactly right.
Or get up out of his chair to see, make sure that his fellow crew member isn't there at a pinch point,
right.
Getting crushed between
Right.
the tug and the ship.
Right. Something I hadn't thought about. What about the CCTV monitoring on the vessel itself? Does the vessel have remote cameras that feed into the wheelhouse?
So that's all part of ABB's Marine Pilot Vision. So we have all of these inputs, into the operator, but will the operator use them, right? So we don't want to overwhelm the operator with new information and new technology. It's there, it's available, but we're also doing some studies to understand the human interface impact of all of this additional technology. Think of, the cars that we have today. I love adaptive cruise control, right? I'm used to it, I understand it, but right when it came out, I don't want someone else controlling my car. I don't want the car braking for me. So it's all about understanding the impacts of technology on the mariner. So it's there, and that's what this whole platform was set up for, to have the technology available, should we choose to integrate it and use it for the mariners of the future.
So, Dave, what do you think is going to be the greatest challenge that we will face in maintaining safety and, going back to what Cole said, the greatest challenge in fitting humans into this new environment?
Again, I think the greatest challenge is just what Cole said. We have all this technology. I would love to throw even more technology on this type of vessel. We got to be very, very wise on our approach. We really do. And we have all kinds of different things that, again, you could throw in there. We could have a whole wheelhouse instead of windows. They could actually be TV screens that would be the windows that would see through. Actually, that's our remote operations. That's what they see, is we have TVs set up that look like the wheelhouse.
So the remote operator is acting as if he's inside the wheelhouse itself.
Yeah, he's in a wheelhouse remotely.
And he has a 360
degree vision. So we could do all that, but then, geez, everybody's going to be terrified. It's no different than when Z drives entered the inland market as part of the shipyard. Everybody was terrified of the new technology, but there's a lot of them out there now. So it's really being wise on how we, and guys like Crowley, how they introduce it into their fleet and get the most bang for the buck first, and then let's put the icing on the cake.
Yeah, to your earlier comments, I don't know that we can fit much more in this. Masterboat,
right.
Has worked really hard, with us on the design side and on the operational side, along with ABB, to really try to maximize, the space on the vessel. And we're putting a lot in a small package because the operators, they don't want a big, large vessel, right? They want a small, compact vessel that fits the harbor, that meets the operational requirements, but they want it to have the power, they want it to be, functional.
And I understand the keel is being laid now.
That's right, keel is being laid as we speak. Yeah, hopefully, Garrett there with Masterboat gets some nice pictures of it, and hopefully that'll be a press release here later in the month.
And on Masterboat side, they are invaluable, I would assume, in giving you guys the parameters that you need for where you can put stuff and how you can channel and lay your wiring trays.
That's right. We optimized the battery room, to really, fit the batteries, I guess the 6.2 megawatts into the vessel. So that was optimized, after the contract was signed with Masterboat. Masterboat provided us, valuable input of, this is our experience in building vessels. They built a lot of tugboats. They are kind of one of the best workboat builders right now.
They built hybrid vessels before,
that's
hybrid
correct.
tugs, I believe.
That's correct. And then we 3D modeled, the wireways, the major cables, from the batteries to the switchboard, back to the drives, just like it was pipe, because the mechanical systems on this aren't mechanical; they're electrical. So we need to treat them, very similarly.
And that's, I got to go back to something you just said. Again, I'm an old engineer. Started out on the draft board, and then we went to AutoCAD, all 2D. Look how quick we're all to 3D now, and just the transition in technology and how we're building these vessels, not let alone what the technology is on the vessel itself. So this technology hurricane, in a way, is just picking up more and more power behind it and getting quicker and quicker.
And the development from 2D to 3D is a quantum leap
for sure.
in ship design, isn't it?
It'll be the same thing again when this tug comes out. My belief, as Dave Lee at ABB, it's going to be a quantum leap on the tugs that are going to be built coming up in the next few years.
And this was a huge advantage with the operators. So as we were building this, they could see, hey, this is the size of the components that we're trying to fit in this space. This is what we're trying to do. Oh, that doesn't work, let's try this. I mean, instead of, it was all done real time. It wasn't, the traditional approach of doing a 2D drawing and sending it across the table and say, hey, what do you think? It was done together collaboratively with the operators, which is one of the advantages, that Crowley Engineering Services has, is we've got operators who have, hundreds of years of experience to develop the best platform.
What do you think is going to be the future in terms of, and this would be for both of you guys, in terms of where we go from here? We know, we can see that there will be improvements in batteries, there will be improvements in systems and so on, improvements in command and control. But taking a leap beyond that, what do you guys see?
So if I get my crystal ball out,
Right.
And
Exactly.
if people know me, it's pretty dim, so I can't see into it very well. But in my crystal ball, it's all these things we're doing today are stepping stones to new technologies, new fuels, everything out. It's not one size fits all. I would love to be able to take batteries and put it in every single vessel out there, but it just doesn't work out for every single one of them. So it's going to be these, I think, a hybrid on top of it. And again, now solid state batteries come out, and that could change the ball game at that point in time. And we start talking about green ammonia, green hydrogen. You know, all those things are going to start flooding into us, and we got to keep up with that technology in an industry that normally is pretty slow to adopt any of that new technology. So that's the biggest one for me, is how quickly you're going to adapt it compared to how quick it's going to be developed.
Yeah, and you know, to what you were saying earlier before, you know, this vessel was laid out so that we can, you know, take the advantages of improved technologies, battery technology, you know, operational efficiencies gained by having this fully electric tug, you know, but we also want to do it in our sustainable way. So what's going to happen, you know, tomorrow? I think there's going to be a lot more e-tugs, you know, and I don't think it's going away. They're going to get bigger, they're going to get more powerful, and I think it's going to be the operator's preference is to have you know, a fully electric vessel, or at least a hybrid vessel.
And not just the operator, but the owner, the port, the customer, and the vessels that surround you, the vessels in your way and the vessels that you're escorting.
That's
everybody
right.
Everybody benefits.
That's right.
That's right. Reducing that carbon footprint from well to wake.
That's right.
Well, I think that we've got a pretty good handle now on what we're dealing with this groundbreaking tug, the E-Wolf, and we certainly have to respect Crowley's and ABB's input into a very, very challenging mission, which is to drag this industry, kicking and screaming, into the future. We thank you very much for joining us.
Good?
That's it.
All right.
That was 30 minutes.